Chapter 2 of Applying UML and Patterns by Craig Larman focuses on iterative development. In contrast to waterfall or sequential development, iterative development involves early programming and testing of partial systems. Iterations of design, coding, integration, and testing are repeated throughout the life of the project. Development starts before all requirements are defined in detail, and feedback from customers is used to clarify and improve evolving requirements. To Larman, iterative development can be seen as getting closer and closer to the most appropriate requirements and design, or the true path, for the system you are trying to build. Each iteration consists of design, implementation, integration, and testing, and each iteration brings you closer to the true path. In the initial iterations, you're far from the path. In later iterations, you're closer because major requirements changes are less likely to happen. However, on the rare occasions when they do occur, you should view them as an opportunity to gain an advantage on your competitors. The idea is that major requirements changes are likely to affect not only you, but also your competitors. And if you are doing iterative development while your competitors are not doing iterative development, you will have a competitive edge, as iterative development is more adaptable to change. Iterative is contrasted to waterfall development, so Larman wants to show us a few of the problems with waterfall development. This graph indicates that as your code gets larger, there is a greater likelihood that your requirements are going to change. But that would be true even if the percentage of requirements change were constant. For example, if you expected 20% of your requirements to change in any given project, then you're probably going to have to modify about 20% of your code. The more functions you have, the more code you have to change. But this graph is telling a more serious story. If you have 10,000 functions in your code, you will likely have to modify 30% of your functions. So 3,000 functions modified rather than only 2,000 functions. Another problem for waterfall development is focused on requirements and the features that your customers want to add to their software. It turns out that a lot of the features that customers want in their software are rarely or never used by the end users. If that's the case, then a lot of time and money is being put into designing, implementing, and testing features that are simply not used. While it's not 100% clear that iterative development would solve this problem, there does seem to be a much better chance for it to do so. If you develop your software in increments of working software, as iterative development does, you can get much faster feedback, not only from the customer, but from the potential end users of the system. Larman cautions us against superimposing waterfall development on iterative development. You may be told you're doing iterative development, but if most of the requirements are written before you start coding, then you're not. Likewise, if your team is trying to create a lot of detailed models before you start coding, then again, you're not doing iterative development. Let's walk through what an iterative project might look like. Suppose we have a project that we think is going to take about 20 iterations. In iterative development, the requirements evolve over a series of early iterations. Each of these iterations will include a requirements workshop. Since these early iterations are focused on requirements, this is where you might build prototypes to help you understand those requirements. It's also where you would build design prototypes to help you nail down the system architecture. Perhaps after 4 iterations, you'll have about 90% of the requirements and about 10% of the software. Once you have most of your requirements defined, you can move into a phase where the iterations are more focused on construction. In the unified process model, which is what Larman uses in the book, this initial phase is called the elaboration phase. Now let's take one of these iterations and look at it in some detail. This is a sample 3-week iteration. We assume that a planning meeting has already taken place the previous Friday, so the team knows what they are supposed to work on. Then the entire day on Monday is devoted to modeling and design. Once the team has a good idea of what their design is going to look like, they jump right into coding on Tuesday of the first week. Coding and unit testing happens in parallel, and the construction activity lasts for more than 2 weeks. That's over 2/3 of the iteration. Somewhere near the middle of the construction phase, there's a question about descoping. This is interesting. If you read Chapter 2 of UML Distilled by Martin Fowler, you should know why this question is here. So before we go any further, I'd like you to pause the video and consider why this question is here and what exactly it means. Ready? This has to do with time boxing. Time boxing means that the delivery date for an increment is fixed, and no matter what happens, you have to deliver working software at the end of your increment. If by some chance you realize that you underestimated the time it would take to deliver the functionality you promised, you must slip functionality rather than push back the delivery date. In this case, the question of whether to descope is the question of whether to slip functionality. Okay, let's get back to our schedule. The last Tuesday of the iteration, we freeze the software. Remember, at this point, we have working code. On Wednesday and Thursday, we demo the code and discuss the requirements. Are the implemented requirements sufficient? Should anything change based on the requirements we implement? And what requirements are we thinking about in the future? On the last day of the iteration, we have a planning meeting to decide what precisely we intend to implement in the next iteration. Larman uses the unified process throughout his book as a working example of an iterative development process. The unified process model makes heavy use of UML diagrams. Now, formal descriptions of the unified process give a list of the many UML diagrams and other work products that can be used throughout the process. Perhaps because of this, some software developers see the unified process as evolutionary but not agile. In other words, they see it as a heavyweight process rather than a lightweight process, because there are so many different kinds of work products associated with it. Larman believes that this is a misreading of the unified process. He reminds the readers that the activities and the artifacts associated with the unified process are optional, and he insists that the UP performs well as an agile process model. Here's what Larman says about using the unified process in an agile manner. First, prefer a small set of UP activities and artifacts. All UP artifacts are optional, says Larman. Don't create them unless they add value. While some projects may benefit from more artifacts, most will be better off if you keep things simple. Remember that requirements and designs are not completed before implementation. They will emerge through your iterations and through the subsequent feedback you get from your customer. Apply the unified modeling language with agile modeling practices. In other words, use UML diagrams as a sketch to work out a design. Do not use them as documentation that will need to be maintained. There is no detailed plan for the entire project. You can make a high-level plan, called a phase plan, that estimates the project end date and other important milestones. And you can make a detailed iteration plan that plans the details of one iteration. But you cannot make a detailed plan for the entire project. Here are some practices that Larman says are critical when using the unified process. Many of these are standard iterative development practices, like continuous feedback, continuous testing, using use cases, and using UML as a sketch, and managing requirements. But I think two of these stand out. The first is the notion that you should tackle high-risk and high-value requirements early. This is consistent with the business notion that if you're going to fail, you should fail fast. Design and implement your riskiest requirements first. If they present too big of a challenge and you need to abandon the project, then at least you found out early. One reason that this is important is that our tendency is to do the opposite. We want to implement the things that we know how to build first, get ourselves some positive feedback, and then try the risky things. But if the risky things we implement later on turn out not to be feasible, then we've just wasted a lot of time and effort in building the easy things. The other point I want to emphasize here is the notion of building a cohesive core architecture in the early iterations. This means that you should come up with your big picture design early so that the subsystems and the components you create later on can be more easily integrated into the system. This is something that's really emphasized in the unified process model. The unified process has 4 phases: inception, elaboration, construction, and transition. During inception, you should come up with a rough vision of the project. You should make the business case, understand its scope, and have vague estimates of time, money, and functionality. During elaboration, you should refine your vision, implement the core architecture, resolve high risks, and you should have identified most of your requirements. Now that you've begun implementing the project, you should also be able to form more realistic estimates. The construction phase will take up the brunt of your effort. In these iterations, you will construct the remaining lower risk and easier elements, and you'll prepare for deployment. The transition phase consists of beta testing and deployment. Here's a graphical view of the phases of a sample UP project. In this project, there's 1 iteration of the inception phase. There are 3 iterations in the elaboration phase, 9 in the construction phase, and 2 in the transition phase. Each iteration is going to add functionality to your product, and each iteration will consist of all the activities from a standard waterfall model: requirements gathering, analysis, design, coding, and testing. This graph gives you an example of the amount of effort you spend in the typical waterfall activities in each iteration of the unified process. In the inception phase and the early iterations of the elaboration phase, lots of business modeling and requirements gathering takes place. In the elaboration phase, you have a substantial amount of each of the activities. In the construction phase, business modeling and requirements gathering decrease, but the other 4 activities, analysis and design, coding, testing, and deployment, are still strong. Remember that deployment can mean internal deployment to your customers rather than a formal release. In the transition phase, you're focused more on testing and deployment. But a key thing to note is that potentially all of the activities can take place in each of the phases, and specifically within each of the iterations. And that's it for this brief introduction to Larman's book on object-oriented analysis and design. I hope you found it interesting. This is Dr. K. I'll see you in the next video.